starting. There we go. All right. Well, it looks like we've started. So welcome, everybody. Welcome again to Astronomy Daily Live. Hope everybody's doing well out there. This is a daily live stream. It starts every single day at 2 hours UTC. And we sit around, gather together here in sort of our virtual porch, sort of a circle of friends, and we think and talk all things astronomy and science and space and you know, all kinds of nerdy things. And you know, this live stream is for everyone. So you know, newbies, for sure, come on in. Any of the like the amateur crowd, come on in, and the pros too. You know, the pros are very, very welcome here. We'd definitely like to get some pros in to, you know, do some pro talk. So yeah, you know, if you are any one of those, you are extremely welcome to come in here. So yeah, you know, grab your favorite consumable of choice and you know, sit back and let's just do a casual, fun get together, talking all things astronomy and space and science. You know, like I just said. So yeah, I hope everybody's doing well out there. I was sort of hoping that it was going to be clear here tonight. We had fog until like 1:30 this afternoon, which is can't say as I've ever seen that here that late, but just, I mean, fog most of the day, which is just, it's just a little weird. So, but you know, that's how things go. You know, there's no such thing as an average day. Average, you know, the concept of an average is a statistical thing, and average doesn't really exist. You know, you can't really point to average. You know, point to an average person, right? They don't exist, right? You know, we're all, you know, extremely unique in so many ways that you know, average doesn't. Yeah, you know, it's just a hard thing. So, you know, the fact that I had fog here until 1:30 this afternoon is definitely not average at all. But you know, that's what makes things extremely interesting. So, so speaking of not average, got some folks in the panel here. Hey there, Bobby. Nice to see you.
Hey, what's up? Hey, I just want to let you know that I just posted a link on the YouTube chat. If anybody loves radio or anything radio related, I have posted a link on the YouTube chat, and this is something that me and a good friend of the radio community known as Ethan Best just made just now. He made the server, I made the rules. So yeah.
Very cool. Very, very cool. You do know that video killed the radio star, right?
I don't think so yet.
You are aware of this, right? So
I don't think so yet.
So I hear. So I hear, right? And we've also got Tom on the panel. Hey there, Tom, with a wider view. How's that working?
Well, so far, I guess it's okay. It's got a little different color to it too, so we'll see how it goes. Mm-hmm. But hope everybody's doing okay. My weather here is not normal either, if I can say that. Got up to over 50 degrees today, and our usual high this time of year is about 30, 31, something like that. So weather's acting a little weird so far this year, but this is better than the normal, I guess. So,
and yeah, like I always say, enjoy it while it lasts. Because it won't.
No, probably not. Probably get back to more seasonable.
Mm-hmm. Yeah. Wow. All right. Well, I'm gonna look in the chat really quick, make sure that all is going well there. Uncle Bill, nice to see you in the chat. Cool. Very, very
Hello,
cool.
Uncle Bill Doran. Or Bruin.
He
I'll
actually
get it right.
he popped in early. 9-inch colas. Nice to see you. Hope everything is well in your world. Yeah,
Cheers, 9-inch colors.
things are going good here. Like I said, I'm actually recovering now a little bit faster. I've been working on these stereoscopic pictures, and you know, the first couple times I worked on those. I worked on them for like hours and hours and hours, no problem at all. And then like the third or fourth time, I spent like 2 minutes, and I was dizzy like the entire rest of the day. And now it seems as though I can sort of work on them for a little while, and I'm only dizzy, you know, for maybe an hour or two. So, you know, right now it's like everything is spinning. But if you go over to my Discord channel, over Discord server, over on the art channel, I posted a few new things over there. Some magnetometer data from Maven, which is a spacecraft that's going around Mars. I also posted some telemetry data, just some random telemetry data. I literally have absolutely no idea what that is at all. I just sort of plotted it, you know, 3D, and then I turned it into a stereo thing. So take a look at that. I also posted another field of stars, right? So I can go over to Gaia, and I can get, for instance, I can get right ascension, declination, and parallax, right? Those three things, they sort of give us 3 dimensions already, and then I stereo those, and you know, it's kind of a neat thing. Yeah, you know, this is part of a project that I'm sort of working on, you know, the artsy fartsy stuff. And I'm thinking, you know, if I can make something relatively interesting there, then there's a local art show at the University of Arizona, and it looks like it's happening in the fall. It usually happens in February of each year, but I noticed that they've sort of postponed it until the fall, which is actually good for me, because there isn't anything new that I've got at the moment. But I think if I can get these stereoscopic things sort of worked out and find something interesting, there's a possibility that those things are going to steal the show. So you know, that really isn't the intent, but you know, if that takes place, I'll be extremely pleased with that. So yeah. All right, well, cool. I hope everybody's doing well out there. You know, I think I want to finish up our linear least squares fitting to that data today, and I sort of cheated a little bit. When I started this, it's like, you know what, I'm not going to touch any of that, except doing the live stream. But I was seeing a few things during the live stream yesterday that I wasn't too happy with the C code. It really wasn't dealing with those floating point values really, really well. And so it's like, well, I'm going to look at that a little bit harder today. Since I was fogged in here, I decided to stay home because people here aren't used to driving in the fog, and so with only 20 feet of visibility, I don't want to be driving on the road at all. That's just that's crazy. Hey there, ERRT Radio. Nice to see ya. So yeah, I was looking at that code and it's like, well, this isn't really behaving the way that I want. So what I did is I switched languages. I went from C back to Perl. So and Perl, I guess, is a language that's sort of not gonna, well, yeah, it might be one of those dying languages. I think probably, what I should do is probably get back into Python. Python I first used in about 1994, 1995, when it was just coming out. And I really haven't done much since. So, this is probably, a good excuse to get back into Python a little bit there too. I always find, that if I have some kind of project, to work on, then programming languages, I'll sort of want to do it, right? I can't really, sit down with a book and go through all the examples and everything. That just doesn't work for me. That's kind of boring, tedious work, But if I have a project, then those kinds of languages are a lot easier. And Ron, I am totally with you. I do too. So yeah, and just a quick shout out here to Mark D'Antonio. He has and actually he's been doing this for a while. Let me go over and see if I can find his YouTube channel really quick. He's doing some pretty cool stuff over there. He's doing a bunch of things. One of the things that he is doing is a live stream pretty much whenever it's clear. Now, he's over in Connecticut, and he has an observatory. I think it's a 10-inch of some sort, but it's pretty much all remote controlled, right? So he sits in a nice, comfy room and does a live stream from there. Basically, showing things off and talking astronomy, right? And he is having a complete blast. So I'm going to put a link to his YouTube channel over on the chat there. So definitely check him out. He's got a nice following. He's created a nice community over there. And, he knows his stuff too. So definitely check him out. Like I said, I don't think he is live streaming every clear night, but I think, he's trying to do it like as much as he possibly can. And, he's a typical astronomer, right? He's like, okay, look, I'm going to do this for 2 hours, right? I'm going to live stream for 2 hours, and then I'm going to cut it off, right? Well, 2 hours goes by, 3 hours goes by, 4 hours goes by, and he's still, doing it, right? Because, he's in a comfy room, and he's having a blast, right? And he's got, somewhere between, 60 and 100 people viewing, the live stream. So it's an active chat and everything else. It's a really, really great community that he's built around him. And yeah, it's a lot of fun. So I've been trying to get over there from time to time, and ERRT radio pops in over there too. So that's a lot of fun. So, all right. And speaking of ERRT radio, Ron also has a live stream over on Mix. I think is it Mix LR? Is that how to pronounce it?
MIXLR.
LR, yeah. So I don't know how that's actually pronounced. If it's MixLR or Mixer. We humans like to mess with those kinds of things. So yeah, definitely check out ERT Radio's live stream over there. He seems to be doing it more in the morning, and he's Central Time in the United States. So definitely check that out too. Do I have a link to that? I probably do. Let me find that one too. MixLR, and then we're going to get to this fitting the data to a straight line. I want to finish that up so we can move on to other things. 9 a.m. Central Time. There we go. So, all right, well, cool. All right, so let me pull up the window here that we were looking at, and I will show you what I've done. Like I said, I switched to Perl, just because it looked like it was a little bit easier to work with. I'm gonna hide that, go to infinity, and pop this up. So as you recall, what I am doing is just taking these equations, right, for delta, A, and B, and plugging everything in, right? It's called plug and chug, as they say. This A and B here is just the slope of a line and the intercept of a line. So these are the two numbers that we actually want to solve for, and of course we're going to let our data tell us what those lines are. We're going to do what's called the best fit, or at least squares fit, and there's some math involved, which you can sort of look at by yourself, because it's calculus, a little bit of calculus, a little bit of linear algebra. So, but we're not going to get into that. What we really want to know is just what A and B are, right? Once we have that, then we can go back up to our first equation, plug in some values of x, calculate some values of y based on the simple equation, and see what kind of plot we get. I mean, it should be a line, right? I mean, it's got to be a line, but we'll see how well that line actually fits the data. And like I said, the thing that I'm most interested in is actually whether the slope of these three lines, expand this a little bit. The slope of these 3 lines that we're going to fit to this data are about the same. And, you know, it's kind of hard to tell. It's a little bit hard to tell because, you know, there's a lot of scatter there, and yeah, don't exactly know. So, like I said, I sort of have moved to a language that's called Perl instead, and I'll sort of walk you through what I've done here. I'm not going to go into extreme detail, but what I've done is I've saved my X and Y values exactly the same way, you know, in these big long lists. And in this case, what I can do with Perl is I can actually separate out the columns, right? So in this case, I'm interested in this column here, which is column 0, right? And then 0, 1, 2, 3, 4, 5, 6, column 6, right? So this column is my, are my X values, and this column here are my Y values. And as you can see, you know, the columns are separated by spaces, right? So that's all I'm doing here in the code is I'm just saying, you know, separate these out by using all the spaces. And then I'm grabbing column 0 and column 6 and putting them into variables that I'm calling XX and YY, okay? Then what we need to do is we need to solve for all of these different S's, right? There's a bunch of different S's here, which are just different sums, right? So you can ignore the sigmas here because I'm going to assume that those numbers are all 1, right? So, you know, something divided by 1 is just the same thing. So, so I'm not worrying about the sigmas here. So I've got an S, which is just the sum of 1 going from 1 to n, n being the number of data points, right? So I think in this case I've got 131 of them. So in the case of S, I'm just going to add 131 times. And I've got a few other values here, right? S sub x, S sub y, S sub xx, which is just x squared summed over all those things, and then sxy, which is x times y, the sum of those. So that's what I've done here, and I've simplified this a little bit. I put everything into one big loop, right? So I've got to set everything to 0 first, right? And then these things, as you can see, right? S, I'm just adding 1 each time, right? Just like it says here, right? There's a 1. S sub x is the next one here, and that's just the x's. S sub y is just the sum of the y's, and then sxx is the sum of the squares of the x's, right? So I've just taken x and multiplied by itself, and then the sxy's is just the x times the y summed over that entire thing. And then I'm just printing those numbers out just to, you know, sort of a sanity check. And if we do this, if we run this for one of the input data files, we get that. And this seems right. You know, there should be 131 here. This is the sum of the x's This is the sum of the y's. This is the sum of the x squares. And that is the sum of the x's times the y's. So that I think all seems to make sense, right? So once we have that, now we can finally solve for A and B. So these look complicated, but really it's just a matter of plugging and chugging, right? So let's do it, right? So A is going to be this big thing here. Let's solve for delta first, because you can see that delta is actually in both of these equations, right? So let's do that first. So delta is going to be S times SXX. Okay, so we're going to go back over here. And I'm going to comment this out because we don't need to print that out anymore. And I'm going to say that delta is S times SXX minus the S of x squared. So let's see, we're going to do it like that. Let's separate these out a little bit with parentheses just to make sure that telling the machine exactly what we want here. Now, did I S of x? Okay, yeah, okay. So S of x times S of x, right? That's S of x squared, right? So that's our delta, right? Our A is going to be this big mess. So S of xx times S of y. S of xx times S of y. And I need to put a $sign in there. That's what Perl likes. Minus S of x times S of xy. There it is. Minus S of x times, what's it, S of xy? Is that right? S of x times S of xy. Let's make sure. S of x times, yeah, okay. And then, of course, all of that is going to be divided by delta. Like that. And so, similarly, B, we're going to go through the same thing here. And in fact, what I'm going to do is I'm going to scooch this window over so I don't have to keep going in between these. So B is S times S sub xy. S times S sub xy minus S sub x times S sub y. And then that whole thing is going to be divided by delta. Divided by delta. Like that. I think that should do it. All right. Let me check my math here again really quick, or my code here really quick. So S and S, SXX, SSX, and then minus, and then S sub x squared. Yep. And then A is going to be S sub xx times S sub y, and then minus S sub x times S sub xy. And that whole thing is divided by delta. Whoop, sorry about that. Come here, you. And then B is going to be S times S sub xy minus S sub x times S sub y. And then that whole thing is divided by delta. Yay. Okay, I think we're good there. Let's do a quick sanity check here too. Make sure that nothing's too crazy looking. Let's just print out delta and A and B. So for this first one, right, we can sort of look at this plot. It is. If you look at the top plot, right, A should be the Y-intercept. So that should be, my guess is somewhere around like 45,000, right? So that's sort of a sanity check here. Let's see. Oh, that says 11,000. Now, why is that? That doesn't seem right to me. 0, 0. Yeah, that should be around 45,000, shouldn't it? And it's not. So let's see. This is part of the process. That's how these kinds of things go. Minus S sub x times S sub x. Wondering why A isn't around 45,000. I'm thinking that it should be. Why wouldn't it be? A and B. I don't think it has anything to do with the name of the variable. That should be okay. S sub x, y, S sub x, S sub y. Why would that not be what I'm expecting? Not exactly sure.
You're missing a dollar sign, aren't you?
Where?
In the delta statement, you've got $S underscore x times S underscore x. Where you're calculating delta and you're squaring it. One of those doesn't have a dollar sign.
Yeah.
And you can also write that as * too, if you don't want to put the variable name in there twice.
Oh, cool. Right. So yeah. What you're saying is I could do that.
Yeah.
Is that right? Yeah. Okay. Well, cool. I'll leave it like that, just to make it easier to sort of read. But yeah, okay, that would make a huge difference. See, it's just one character, right? So
yeah, and there's an option you can set that you'll get warnings about that stuff if you run into that again.
Gotcha.
I can't remember what it is. I could find out for you. But.
Yeah, that's all right. There we go. So 46,447. That is much more logical. Yeah. Let's we can actually look at these other ones. So target 001 should be around 23 or 24,000. Yep, 24,000. And target 002 should be, I don't know, around what, 8,000 or so, something like that. Yeah, 8,800. Yeah. Okay. That makes sense. However, I'm looking at these slopes, and I'm seeing that all the slopes are different. pretty significantly different. So, don't know what's going on there. Let's finish this though. What I want to do is I actually want to make these lines, right? So I'm going to comment that out, and I'm going to do exactly the same thing. So as you can see, the equation for this line is that y is going to be a function of x. So for any x that I put in here, it's going to calculate a certain y, right? So let's use the x values that we have, right, stored already here, and calculate some new y values, which should be part of a line, right? So let's do that. Let's call it, and in fact, I think what I'm going to do is I'm going to do it like this. I'm going to call it new YY equals $A plus $B times the x values that we have, like that. And then we can actually just print those out right here, like that. We'll call it XX of I and our new YY, that. Okay? That'll do it, because I'm going from 0 to I, and I is still, you know, just a number of data points.
Shouldn't new y be using the j variable there?
No, I'm just calculating it right on the fly. I'm not going to save it.
No, I mean where it's got %XX.
Oh yeah, yep. You're right. You're right. All right, Tom, you're hired. All right, cool. Oh, and here too. Yeah. Yeah, because J in this case is our counter, right? So J.
I's not changing, so you'd get weird stuff.
Yeah. So J is going to go from 0 to I minus 1. And yeah, so if this was I, it would try to be, you know, I mean, it would definitely try to do something, but that really isn't a valid number, right? So yeah, definitely have to use J there. Yep. Okay, cool. Let's run this, and what we're going to get, I'm going to redirect the output to another text file, and let's call it line 000, like that. And then let's look at it really quick. So there they are. So in theory, when I plot this now, that should be a straight line. So let's find out if it is. Let's go over here, and we're going, I'm going to expand this a little bit. So let's plot the original data, target 000, using 1 and 7 points. Use points just so we can look at the data points and not be confused by any kind of lines or anything like that. Color 8, and then we're going to do work line 000 using add typing day today. Points 7, point size 1, and let's use a different color. Ammo. There we go. So that is a best fit line to this first set of data. And as you can see, you know, we do a pretty good job looking at data and being able to fit a pretty good line, with our own brain. So, if we just look at the data here, right? Yeah, it's going to be going about like that, and lo and behold, it is. So this is all broken up, of course, because I'm using the actual X values, and some of those just don't exist, right? So yeah, I think that did a pretty good job. Let's do it for these other ones. We'll do it for line 1 and line 2, and we'll do exactly the same thing here. We'll just do line 1 and target 1. See what that looks like. Ammo, pretty good. Not too bad. Looks like a pretty good fit. I mean, the math says that this is as good a fit as it can be. And yeah, I can believe that. Let's look at the last one really quick, and then we can sort of look at this in a different way and see if there's anything else interesting going on there. So, okay, yeah. So there's another fit to that data. Now, let's make a really, really, really busy plot here. Let's do that and that, and my poor screen is going to have fits, but I'm going to do it anyway. We'll be all right. Target.
I'd like to welcome Ray right now in the chat.
Hey there, Ray. Oh, that didn't work out the way I wanted it to. Target. Oh, haha. I'm looking at the wrong thing. Yeah, my screen has a little bit of fits when it's in this mode, so we just sort of have to put up with some weirdness here for a second.
Yeah.
So here's the here's the data again. It's done. So here's all the data. So now what I want to do is I want to do all the lines. We'll do that. Oh, I want to do 0 first. We can go back and do this. This is going to be a busy plot. That one and that one. And we'll see everything. There we go. So there's our data with the black dots, and our best fit is with the red dots. Our best fit using a line. So yeah, that seemed to work okay. The interesting thing is, and now I'm going to have to go back and think about this, is let's actually switch this back. Let's not print out the data values, but just look at A and B. Really, that's really the only thing I'm interested in here. Because A is the Yintercept, and actually the most important one, the one that I'm mostly interested in, is B, which is the slope of these lines. And my guess was that the slope was going to be pretty much the same for all of these, but I don't think we're seeing that. So target 0, we've got a slope of 21.38. Target 1, we've got a slope of 14.45. Target 2, we've got a slope of 4.46. So those are all very different. And those, just as a reminder, right, those correspond to, what, do I have that? Do I still have that up here? I think I do somewhere. Yeah. Whoop, that got really small. So in this case, target 0 is this star, target 1 is this star, and target 2 is this one, right? So bright, fainter, faintest. So these are all, I mean, this is a very, very narrow field of view, right? Right and left here, it's about 8 or 9 arc minutes, and up and down, it's about 12. So it's a very, very, very small field of view. So, I definitely know, that the moon was rising, which is why I think I've got, these slopes at all, because I'm measuring the brightnesses of these things, and that is going to include some of the sky, right? But in this very, very narrow field of view, I would think that the sky would be pretty much the same here as it is here and here, right? But if that's true, then our slopes, here, well, we can sort of see, should all be about the same, right? And they are definitely, for sure, not, right? So, because I'm doing what's called differential photometry, right? I'm comparing the brightness of this guy to the brightness of this guy. I'm actually looking at the magnitude differences here, right? Between this one and this one, and this one and this one, and that one and that one. Well, if the slopes are all exactly the same, then those differences shouldn't be changing over time. But those slopes are definitely different. So I am definitely seeing a change in magnitude differences between these, which is wrong, right? I mean, I shouldn't be seeing a difference in magnitude. On these time scales, no way. This is a series of 200 2-second exposures. So that's, 400 seconds of exposure, and then, taking into account, the download time for the images and stuff. I think this is about, like 20 minutes of time or so. So, the differences in magnitudes should most definitely should not be changing at all. But I'm seeing that these slopes are very different, right? Now, the data is noisy, right? It's pretty noisy, right? Quite a bit of scatter here. But I can sort of believe these slopes now, and what they're saying is that at the beginning of my observation, these stars were a certain brightness, and actually, the ratio between these were a certain difference. But at the end of the observations, they were actually different. Now, what we can actually do in this code now is actually compute those magnitude differences. So this is something that I didn't have planned, but we should definitely do it. I think what I am going to do now is I am going to actually save these values in a new array. So let's do it like this. And like I said yesterday, there are lots of ways of doing this. This is just one way, right? So I'm going to store these. So I've got Y's and X's for each one of those. Yeah, you know what? I don't have to store these. Now, I don't have to store these because I actually printed them out, right? So I've got line 0, 0, 0, right? See, I've got the numbers here, right? Right. What we are going to have to do is we're going to have to write some new code. Let's do it in Perl again. Let's call it mags, like that. So I'm going to basically do the same thing, just sort of read this stuff in like that. Split them up into columns. That.
If you put use warnings in your program, the compiler will tell you about things like where you left off the $sign. And
oh, okay. All right. Yeah. I usually do this really fast, and yeah, I probably should be doing a lot of things I'm not doing. So yeah, there's probably a way too in this Perl thing here, to tell it, to warn me as well. So all right, well, cool. I think for now I'm just gonna keep pounding away like I'm doing it here. So let's see. Actually, I need to read in. I need to read in 2 files at the same time. So I think it's. I never remember what the open command is. It's I'm gonna have to cheat and go somewhere else to find that out. I'm gonna open up a new window here. I think I've got one. Let's see. I think any of these will tell me. That's how we do it. Okay. I'm just going to do it like that. Again, there are lots of ways of doing this. I'm just going to do it this way for now. Give 0. Part 1. That. And let's call this YY1. That YY1 of I, which I have to define, is going to be second column, which in this case is column 1. It starts at 0, right? So the first column here is my X value, which is column 0. Column 1 are the Y values, which is what I want. So that's going to do that. I need a counter in here, something like that. And then I'll close that guy up. That, and then I'll do exactly the same thing for the second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh. We'll call this targ2 just for fun. 2. I think that's right. Whoop, we need bad typing day. It's going to be one of those. That's
Try
right.
doing it at late at night and stuff.
Oh, yeah, I know how it is. Okay, so what I'm doing here is I'm filling up the arrays YY1 and YY2. Those are this column, right, for one file, and of course the same column for another file. Now, if I wanted to, I could really, you know what? Let's do it. Let's do it for all three. I didn't do that right. Let me do this. 3, argument 2, 3, 3. I think I've got that right. Right, so I'm going to open up 3 files, our 3 different star files. We just have to, you know, I mean, it all comes down, you know, to accounting, right? You just have to make sure that you're looking at the right things at the right time.
The line right below that is wrong, isn't it?
Which one?
You've got YY2.
Oh, yeah. Thank you, sir. Yeah, thank you, sir. Okay, I think we're good here. Okay, so let's do this. Unplanned coding, but I like it. Keeps me on my toes. Okay, so what we're going to do is we're going to compute the magnitude differences between those 3 stars. And we can do this simultaneously for all 3, right? So we're going to have 1 versus 2. We're going to have 1 versus 3. And we're going to have 2 versus 3, right? Those are the 3 magnitude differences we're going to calculate. And I'm going to use, you know, the magnitude scale. And in fact, I'm going to have to go back over here and hope that I've got a log 10 function. Yay, I do.
And before we continue, I'd like to welcome Chris Elliott in Astronomy.
Hey there, Chris. Nice to see you. We're writing some code here to, well, we're doing a bunch of things. We just finished writing a little bit of code to do a linear least squares fit to some data. And now I'm going to take those results and compute magnitude differences based on those fits. So I'm going to put that there. So that's my log 10 function properly written. And all right, so let's see. What we want to do is we want to do the ratio between 1 and 2. So mag 1 and 2 is going to be negative 2.5 times the log base 10 of yy1 j divided by yy2 of j, right? So this is, you know, the normal magnitude scale, right? We're going to do this just like we were real astronomers. And we can do the same for 1 versus 3. And we can do the same for 2 versus 3. And that's how you compute a difference in magnitudes. Just like that. I think that's right. I think I've got the math right there. It's pretty simple. I think you just take the ratio of the fluxes, which that's all these numbers are just fluxes, right? It's just brightnesses. And we want to look at the ratio between those. And then multiply the log base 10 of that ratio by negative 2.5. That will give us a difference in magnitudes. And I think that's right. So so let's actually print that out. And we'll print out our original x's too. Whoop, I've got a little typo there. So %f, 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 %f. So we're going to print out three different values. The first is going to be our array of x's, like that. And then the last three are just going to be these three dudes here that we just calculated. That. And what we're going to see is that these change, right? At least that's what I'm expecting. And the thing of it is that they should not be changing, right? If it's just the effect of the moon rising, which was happening, right? You know, the sky was getting brighter during that time, but the brightest star seems to be getting brighter faster than the fainter star. So I'm going to have to think about that, but I sort of want to see how much, right? And that's what this exercise is all about. So I think I've got all that right. We're going to find out really quick here. So this is just the difference in magnitudes, right? I mean, I'm not actually computing the magnitudes themselves. That would require measuring a standard star, and you know that's just way too much hassle. Yeah, well, we can think about why there would be differences in this, but let's see if there actually are and to what extent they actually are. All right, so I've got to change this to an executable. That. So it's going to be mags PL. We're going to do line 00, line 001, and line 002. And let's output that to mags. Let's just call mags all. Yeah, there we are. So what this is showing, of course, is the difference in magnitude between, oh, that's not quite right. What did I do there? Probably didn't. XX. Oh, I didn't actually read those in. Let's do that. Oh, and what did I do here? And what did I do? I've got 4 read-ins here. We don't need that one. There. 1, 2, and 3. I don't know how that got. I don't know how that got in there, but let's do one of these for the x's. All the x's are the same. All right, so we can just do that, and that's going to be 0 like that. So yeah, those numbers may not have been right. YY1, YY2, YY3. Okay. Let's try this again, and oh, it's still not there. What am I doing wrong here? Code writing. On argv of 0, It is argv of 0, or is it argv of 1? Is that the first one? I never remember that. Maybe it is. Is it argv of 1, argv of 2, argv of 3? Could be.
There is an argv0, but that might be the program name.
Yeah, that's what I was thinking, but I'm going to put in this because I know that normally should be there. I thought I'm going to go back over to my cheat here. Yeah, that should be argv of 0. Okay, so that's right. Argv of 1, argv of 2. Looks right. All looks okay. Oh, haha, it's not XX, it's XX1. I'm just going to make it XX instead. No confusion there. There we go. Okay, so here's all of our X's, and then here's all of our magnitude differences. And as you can see, they're, as you look down the column here, they do change. They do change, but here's the difference in magnitude between star 1, or star 0 and star 1, star 0 and star 2, and star 1 and star 2. Of course, the largest difference is between star 0 and star 2, which of course makes sense because it's the brightest one versus the faintest one. So, and of course it's a negative because the brighter star actually has a lower magnitude, right? So yeah, it's a weird things, the magnitude scale. So I'm thinking that that's looking correct in terms of the calculation. I think so. Let's look at this one more time just to make absolute certain that I'm reading all this in correctly. YY2, YY3, and then I'm doing the right math down here. 1 versus 2, 1 versus 3, 2 versus 3. Okay, I think that's right. So now we can plot this file called mags_all. Let's plot first one here. Oh, that matters, but I'll do that anyway. Using 1 and 2. So I'm going to use column 1 and column 2 here first. We'll just look at that one. And we'll do it with points again. So this shouldn't be changing, right? It should be just a flat line, no slope at all. But we're going to see that there definitely is a slope. And it's subtle, right? It's going between about negative 0.715 and negative 0.68-ish something. We can actually look at the numbers. Yeah, here, right? So here's the first one. We can look at the last one. So, what is that? That's that minus that. We're looking at 0.0027 magnitudes difference between the beginning and the end. I mean, it should be 0, right? I mean, that's what I sort of expect. But that's definitely not what we're seeing. Let's look at 1 versus 3. Again, we're seeing that. And then let's look at target 2 versus target 3, which is column 4. And oh, wow, it's going down. It's just not, I'm not happy. Not happy at all. Let's look at them all. Let's do that, and we'll do that. That's a little bit harder to see. So yeah, kind of interesting. I don't know. I'm not quite sure. Let's set the log scale of the y axis, or let's set the y-axis to a logarithmic scale instead. Then we might be able to plot all these 3, and it might. Oh, they're negative. Oh no, I can't. I can't do that. Set log scale y. Yeah, we can't. We can't do that. So, well, that's kind of interesting. So over the time of the observation, the difference between this guy and this guy is going up. The difference between this guy and this guy is going up. And the difference between this guy and this guy is going down. So, oh, yeah, I don't know what's going on there. All right, well, that's a very interesting result. I knew that things were changing over time. I didn't expect these two to be going up and these two to be going down. That's a little weird. So yeah, I'm gonna have to think about that one a little bit. I don't have top of my head. I don't have an explanation for that one at all. So yeah, that's a little bit of a mystery. You know, like I said, you know, I was expecting them, you know, to be brightening, but I was expecting them, you know, to be brightening all sort of the same. And not only are they not brightening the same, some of them are brightening in the opposite sense. So, yeah, you know, if I had longer hair, I'd be tearing it out right now.
All right. And before we go, I just once again posted a link to our new radio hobbyist server on Discord, so check it out.
Cool. Yeah, for sure. So, yeah, you know, what we're doing here is a little bit of scientific analysis. This is part of what you know, professional research astronomers do. Is, you know, they look at data and they find things like this and go, what is going on there? What's going on, right? And you know, there has to be an explanation. One possibility, which I didn't think, I don't really think that this is playing into it at all, is this thing called extinction. the atmosphere, what the brightnesses of stars will change or be different depending on their color, right? Because as that light moves through the atmosphere, right, depending on what wavelength of light we're looking at, things are going to be different, okay? But I don't think that that's what's happening here for two reasons. The first reason is that all these observations are very, very broad band, right? I'm pretty much looking over the entire visible range. I'm not using any kind of filters at all, right? Now, the CCD camera itself is sort of acting like a filter. But it's over a very, very, very broad wavelength range. So, so I don't think that is causing this. But I'm going to look at that. I'm definitely going to look at the colors of these stars. I should be able to find out the colors of these stars, and you know, see if the extinction is playing any kind of role at all. I don't think it is, though, for the second reason, and that is because I'm doing differential photometry, right? These stars are so close to one another spatially, you know, right in the sky, that the extinction of star 1 should be pretty much exactly the same extinction as star 2 and star 3. You know, all three of those are basically, you know, going through the same piece of air. And so, you know, the extinction should be working on all three of those stars exactly the same way. And because it's broadband, it shouldn't matter what the colors are. But I'm going to look at that because there's a possibility, right? I mean, if one star is really, really, really red, right, and one star is really, really, really blue, then differentially, there might be some differences there. So yeah, well, this has been a very enlightening kind of exercise, because, you know, it's telling me that I don't really have this thing fully characterized yet, and something else is going on, and it isn't just, you know, the fact, you know, that the moon was rising and the sky was getting brighter, right? Like I've said, you know, several times now, if that was, you know, the case, and the brightness of the stars should you know, they should all be going up at the same time, but they're not. They're not. So yeah, it's a little bit of a mystery, but I like these kinds of mysteries. This is the thing that keeps me going, for sure. So, all right. Well, I think I'm gonna cut this off for today. Hope you enjoyed that. That's, you know, for what it's worth, looking at a little bit of code, you know, looking at, you know, some plots, you know, seeing how some of this is done. It's tedious work, and you know, you can definitely you know, get to a point where it's just like, you know, what is going on, right? What is going on? I don't understand this at all. I'm not at that point yet, but yeah, I will definitely be able to figure this out. I think it's just a matter of time. You just have to think about it a little bit, try some things out, And yeah, you know, we'll see where it goes from here. I'm probably not gonna really do much more with this during the live stream. Sort of, you know, gotten to a really nice endpoint there in terms of, you know, showing you all, you know, the process. But I will definitely keep you updated because, I mean, what I want to see is nice flat lines. You know, the differences between the brightnesses of those stars, they should all stay exactly the same, right? I shouldn't see any slopes at all. And, you know, the fact that I don't know, is it, you know, is it, you know, the camera itself? Is it the atmospheric extinction? Is it the colors of the stars? Is it the position of the stars in the sky? I don't know. I don't know. But I will get to the bottom of it for sure, because, you know, everything that I do to, you know, work these kinds of things out makes my system better, and that is what I want. I want, you know, the best system that I can do. There's every indication, right, that with this telescope, I should be able to detect transiting planets going in front of stars, right? I should be able to see the exoplanets. I should be able to see them. And you know, I was looking at the numbers I was getting, and I'm like, well, you know, that's not good enough, you know, to really see that. But the numbers that I'm seeing here tonight, if I can eliminate those, then, you know, doing things like looking at transiting planets going around other stars, that's a good possibility now. You never know. Now that isn't my end game, but it's definitely one of the end games. You know, I definitely like to be able to offer, you know, that kind of service. That would be killer. I think that'd be very cool. So, all right, well, I'm going to get out of here for now. So thanks everybody for coming in, putting up with this. Thanks, Tom, for checking all my code. You know, most programmers need that kind of help for sure. And, you know, this is one of them. You know, looking over the shoulder, that's awesome. Very awesome. So thanks for doing that. Yeah, you know, and the littlest little things, you know, the littlest different change in character, right, is going to throw you completely off. So yeah, greatly appreciated checking me on those kinds of things.
Sure thing.
All right, y'all, I'm going to get out of here for now. So thanks for coming in. Have a great evening, a great day. Make sure to subscribe if you haven't. Spread the word about this. You know, like I say, much of the time, you know, I'm not trying to teach anything or anything. I'm just, you know, sharing a passion, showing you, you know, the kinds of things that I'm doing, and hope, you know, if nothing else, you know, get a chuckle out of it. You know, because I certainly do. So, all right, everybody, I'm going to get out of here. Take care. I will see you in a little less than one spin of this tiny little planet. Take care, everybody. I'll see you then. Bye.